The next value in all of our transformations that we could look at is our b value. Okay? Our b value, that involves horizontal stretches and compressions. So in part A, we have y equals cos of 6x. That would mean you're going to multiply your x values by, it's a horizontal compression, we would multiply our x values not by 6, but by 1/6. Now, our cos graph repeats itself over 2 pi. Every time you go 2 pi, it repeats itself. And now, that distance from 0 to 2 pi is getting compressed or squished by 1/6. So if our period was 2 pi for y equals cos of x, what happens to that when we compress it by 1/6? Our period will be 2 pi divided by 6 for y equals cos 6x. And you could reduce that to pi over 3 if you wanted to. But for right now, I'm just going to leave it as 2 pi over 6. Okay? We're going to learn and highlight at the bottom of the page our formula for the period of sine and cos and tan. For each of these, we are going to graph. So I'm going to start introducing you a little bit to the shortcut for graphing these. Here, instead of marking 2 pi like I normally do, I would mark 2 pi over 6, which is 1 full period. What is, and we're going to, same thing as before with our axes family, we had this into 4 equal sections. Now we have to take pi over 3 and divide it into 4 equal sections. So if I just labeled this as pi over 3, what's half of pi over 3? Pi over 6. So that would be the second one I would label, because that's the easiest one to do mathematically, half of pi over 3. Can you see that this first one would be half of pi over 6? What's half of pi over 6? Pi over 12. And once you get the first one, you can use, since these are all equal, you can use the first one as sort of like counting. Like if this was 1, this would be 2, then 3, then 4. You guys are pretty good at that. Now it's 1 pi over 12. This one is 2 pi over 12s. Does that make sense that that's pi over 6? This one would be 3 pi over 12s. And you can leave it like that, or if you want to, you could reduce it to pi over 4. But for right now, I'm just going to use the counting technique and say, oh, it would be 3 pi over 12. Does it still work? Is pi over 3 4 pi over 12? Yes. So that is how the b value is going to affect your period, and it's going to change what you write along your x-axis. Okay? Nothing changed the amplitude for this one, so it still goes up to 1 and down to -1. It's a cos graph. Where does a cos graph start? At a maximum. Okay? And then it goes middle, minimum, middle, maximum. Draw your curve through all of those. And we've got our graph. Part B. Y equals tan of 2/3 x x gets multiplied by 3/2. Again, we look at the period of tan. If you look back at your tan graph that you drew the page before, the tan graph repeats itself over pi instead of 2 pi. So the period was pi for y equals tan of x. And if we multiply our x values by 3/2, it'll be 3 pi/2 for tan of 2/3 x. Your tan graph had asymptotes. Your tan graph had an asymptote here at pi/2, because that's where it's not allowed. If I multiply my x values by 3/2, can you see that pi/2, when multiplied by 3/2, will become 3 pi/4? And this one, negative 3 pi/4. So what I did is I took my asymptote. On this one, I have an asymptote at x equals pi/2. Pi/2 times by 3/2 is 3 pi/4. My second asymptote on tan x is at 3 pi/2. If I multiply 3 pi/2 times by 3/2, my second asymptote here is going to be at 9 pi/4. And my tan graph keeps the same shape. And part C, we want y equals sine of x over 7. And so this would be, we're multiplying by 1/7, so that's a horizontal stretch. You'd multiply all of your x values by 7. So if we do the same idea, the period is 2 pi Are you okay if I write the x over 7 as 1/7 x? And I think if I write it as 1/7 x, you can even see better that it's a horizontal stretch. And you have to multiply your x values by 7. So just like cosine, if the period was normally 2 pi and you've stretched it by a factor of 7, instead of marking 2 pi as my first period, I'm going to mark 14 pi. I'm going to divide it into 4 equal sections. The easiest one is halfway. What's half of 14? 7. What's half of 7? 3.5 pi, or you could write that as 7 pi/2. And if this is 1/7 pi/2, and this is 2/7 pi/2s, this one I could write as 3/7 pi/2s. 3 times 7 is 21. The amplitude, what's the number in front, is still 1, so it still goes up to 1 and down to -1. Where does the sine graph start? In the middle, going up. So maximum, middle, minimum, middle. Draw your curve. questions for practice are 3, C, and D, and I just want you to go to the bottom of the page because we're going to add some formulas. Yes? Yeah. So I start with this one because it's my period. I divide it into 4 equal sections, and I find this one's the easiest to find next because it's half of 14. And then half of 7 is 7 pi over 2. And then I just count. If all of these ticky marks are the same distance, this is 1 7 pi over 2, 2 7 pi over 2. This one then will be 3 7 pi over 2s. And how do I multiply fractions? I multiply tops, gives me 21 pi over 2. Okay? So the last thing I want you to do is at the bottom of your page. At the bottom of the page there's this box which has some formulas. Underneath, I would like you to write out these formulas. For sine and for cosine, whatever your b value is, your period will be 2 pi divided by that b value. But for tangent, since your period starts at pi, that horizontal compression will mean that your period becomes pi over b. So this becomes a very important formula for sine and cosine, and this becomes a very important formula for tangent, for figuring out the period. And sometimes we'll be told the period and we want to find out what the b value is. So rearranging these formulas, we could solve for b, and your b value is always 2 pi over your period for sine and cosine, and your b value is always pi over your period for tangent.